This video is a more in-depth look at the elimination of water from alcohols. It's also called dehydration, because you may see several different mechanisms and not understand why there are different mechanisms. So this video explains it. For the UK A-level syllabus, you don't need to know the difference between these two mechanisms. So for primary alcohols like ethanol, for example, the mechanism for the elimination of water, or dehydration, requires the use of sulphuric acid as a catalyst, which has the formula H2SO4, and this is the structure of sulphuric acid. Notice the electron pairs on the hydroxyl group of the alcohol. They attack the hydrogen, break the OH bond, and in this step we call it protonation. The OH group, or the hydroxyl group, is being protonated by sulphuric acid. Now it's already got 2 bonds and it's forming a new bond to that hydrogen, so we give it 3 bonds, and because it's got 3 bonds now it becomes positively charged. Remember, net charges balance in these reactions, so we're left with an HSO4- ion. We call that the hydrogen sulfate ion. So when we're using primary alcohols, that HSO4- ion deprotonates this species, so it takes that hydrogen, breaks a carbon-hydrogen bond to make a carbon-carbon bond, and the water molecules kicked out as a leaving group. And notice that charge is now going to be lost on the water because the electrons are going towards the oxygen. So we form an alkene, in this case ethene, a molecule of water which is now electrically neutral, and we remake our sulphuric acid, H2SO4. So look at that, at the beginning that structure was H2SO4. It lost a proton to become HSO4-, and then it regained the proton to become H2SO4 again. So remember, the definition of a catalyst is something that speeds up a chemical reaction without itself being used up. Also notice in this middle step, we've got 2 species involved. We've got an HSO4- ion, there's one molecule, and we've also got this protonated alcohol, and because we've got 2 molecules, it's called the E2 mechanism. But if you have a secondary or tertiary alcohol, the mechanism is subtly different. So let's look at propan-2-ol as an example. That's a secondary alcohol. Propan-2-ol has a hydroxyl group on the second carbon, and because it's now in the middle of a chain, it's a secondary alcohol, but it's still got the lone pairs of electrons on the oxygen. And we're still going to use sulphuric acid as a catalyst, and the first step's exactly the same. So the electron pairs attack the hydrogen on sulphuric acid, we're protonated in the hydroxyl group, the OH bond breaks, and we form a very similar species where you've got that oxygen with 3 bonds to it now, and it's going to have a positive charge, and that oxygen we stick on the middle carbon, there's the 3 bonds, and there's a positive charge. But this time, instead of our HSO4- attacking one of those protons, that water molecule drops off. Both of the electrons in the carbon-oxygen bond go to the oxygen to make it a neutral water molecule, but that leaves behind a positively charged carbon atom in the middle of this molecule. We call it a carbocation intermediate, and there's a water molecule that's been released. Now the carbocation intermediate is not very stable, but it's being stabilised to an extent by the 2 methyl groups on each side of it. Electrons are pushed down those covalent bonds towards a carbon, and the negative charge of the electron stabilises the positively charged carbocation a little bit. Notice in the primary alcohol you've only got a methyl group or an alkyl group on one side of it, so it's not stabilised as much. And then the hydrogen sulfate ion can attack the hydrogen, very similar to the last mechanism, forming a carbon-carbon bond, removing that positive charge, and remaking H2SO4. Again, notice that because H2SO4 is remade, it's acting as a catalyst, but this rate-determining step now, in the middle, only involves one molecule. The HSO4 molecule is not involved, and because there's only one molecule in that step, it's called an E1 mechanism. So secondary or tertiary alcohols undergo elimination by the E1 mechanism.